Okay, so this is our first video dealing with topic 4, digital logic. And in this video, we're going to cover basically the concept of Boolean algebra and one way or the first way to express a Boolean algebra, which is the algebraic format and the truth tables. Now, so the concept of Boolean algebra is very similar to regular algebra. And the only difference is that in Boolean algebra, the value a variable can take is only 0 or 1, right? So in normal algebra, you can have a variable taking an integer value from, negative infinity to positive infinity. If it's a real value, a decimal value, positive, negative, or 0. But in Boolean algebra, the only thing the variables can take or can be are either 0 or 1. Internally in the machine, logically, the 0 is a false statement, 1 is a true statement, or in more engineering kind of terms, the 0 normally would be a low voltage and the 1 would be a high voltage. In regular algebra, we have, many operations, and in Boolean algebra, the basic logical operations are the functions and, or, and not, which we're going to see in a couple minutes. Now, with these three functions, we can pretty much do everything that needs to be done, and we can even create other functions that are derived from these three. Okay, so let's take a look at these three functions. The not function is a unary, function or operator that takes only one operator or only one variable. So if you have a variable x, and here are the two possibilities for x, 0 or 1. So the not x, which is represented by a bar on top of the variable, if the original x was 0, not x is the opposite or 1. Right? If x is 1, not x is 0. It's just like a negation, right? Now, the end function. The end function is a function that requires two operands. It's binary. So the n and the or are both binary. So if you have two variables x and y, right, the four possible combinations would be both are 0, x is 0 and y is 1, x is 1 and y is 0, or both are 1. Okay, so the end function behaves pretty much like the regular and in the English language, right? So when I have both 0 and 0, the end is 0. When I have either 0 and 1 or 1 and 0 for x and y, both are also 0. And the only circumstance is when both are 1, that's when the end x and y is 1. So you can imagine, the 1 again as true and the 0 as false. So the end is true when only both are true. Now, the OR function, same, it's a binary function which requires two functions. So the four possibilities are again 0, 0, 0, 1, 1, 0, and 1, 1. So the OR case is only 0 when both x and y are 0. The other three cases, the x or y is 1. Okay, so this is the definition of not, and or. Now, let me show you something else that's important for you to observe in these function setups. Notice that for the case where I have only a single variable, the two possibilities are listed in increasing order, 0, 1. When I have two variables, 0, 0, which is 0, 0, 1, which is 1, 1, 0, which is the number 2, and 1, 1, which is the number 3. Again, the possibilities are listed in increasing order. And same thing here, right? 0, 0, 0, 1, 1, 1, 0, 2, 1, 1, 3. So this is normally the way we represent, and when we talk about truth tables in a couple minutes, we are going to always list the values in increasing order when the number or numbers are written in binary form. So here's another observation that's important. The number of total outputs for a particular input is 2 to the n, when n is the number of input variables. So if I have one variable, like in the first case, 2 to the 1 is 2, I'm going to have 2 outputs. When I have 2 variables, 2 to the 2 is 4, I am going to have 4 outputs. If I have 3 inputs, then I am going to have a total of 8 outputs. So this is 2 to the n. And it makes it very easy because the only possible values for a Boolean function or expression is 0 or 1. Okay, so the first way, which is the normal algebraic way to represent a algebraic function, is with the variables themselves, right? So in algebra, you may have a function that might look like this, right? X squared plus 2x, for example. All right. In Boolean algebra, I can have a function that looks like this, AB or not AB, and maybe B or not B, or something as you see over here, okay? The bar on top of the variable represents the not function. So this is the algebraic way to represent a Boolean function, okay? Now, we are interested in, and we should be interested in, determining, this cannot be done very easily if we were dealing with regular algebra, but in Boolean algebra, this is quite possible to determine the set of possible values the function will take when I assign different values to the input variables. So this is possible. And one way to do it is with truth tables. Okay, with the algebraic definition, this is pretty much all I can do. I can state the function and somebody can look at it and say, okay, this is a function, but what are the outputs? I don't know. So the concept of a truth table is going to help us to determine that. Okay, so Boolean algebra is a field of mathematics that is based on variables that can only take the value 0 or 1. They are based on these 3 functions, not, and or, where not is a unary operator or function, and or are binary. They take 2 variables. We can express a function in the algebraic format, pretty much like regular algebra, but we are interested in determining the set of all possible values a Boolean function can take. And for that, we are going to use this concept of a truth table. Okay, so as you can see here, a truth table is just a table as this one right here that is going to list all possible function inputs and the respective output for each input type, 0 or 1, and at the end, the overall value of the function for each of its respective inputs. So it's a very useful procedure to look at the behavior of the function from beginning to end, okay? So this is exactly what we are going to do. So as I mentioned before, if a function has n inputs or n variables, the output will have 2 to the n possible variations. So, like I said, for one variable, for one input, one variable input, I am going to have 2 outputs. For 2 inputs, I am going to have 4 outputs. For 3 inputs, I'm going to have 8. For 4 inputs, I'm going to have 16, and so on and so forth. Okay? Normally, for the purposes of our course, we won't go beyond maybe 3 or 4 because, as you can see, the truth table gets to be a little bit big. So take a look at this truth table here. This function. So I have a Boolean function that has 2 variables. So if the function has 2 variables, I can expect to have 4 different outputs. So then I am going to create a truth table with 1, 2, 3, 4 rows because I am going to have 4 different outputs. So the truth table then begins the following way. Okay. I have to determine how many variables I have. In this case, I have 2. So you're going to write those variables in the leftmost columns. And as I said before, because you have 2 variables, you are going to be allowed 4 outputs. Okay, so that means there is going to be, a variation of 4 sets of inputs. And you're going to write them in order, in increasing order from top to bottom. So 0, 0, 0, 1, 1, 0, 1, 1. So the numbers go from 0, 1, 2, and 3, as you see here. So this is what you're going to write whenever you're creating a truth table for your function. Okay, in this case, it's a function of 2 variables, but we'll see in our next example a function of 3. Okay, next we are going to, or we have to determine the value of the function, which is this whole thing right here. This is the definition of this function at the end of the truth table. So the very last column of the truth table has to be the whole function as you see here. So I'm going to write this thing over here. Now, I already calculated it before. I am going to need this many columns to fully express this function. And I'll explain how I know that. Okay, so the very last column of the truth table has to be the function itself. All right. Now, in the columns between, we are going to have to build piece by piece of the function in the columns. Okay? Piece by piece. So, the procedure in this case begins with, I need a column for not B and not A, because I don't have it here yet. The only thing I have is A and B. So I'm going to create a column for not A and a column for not B. And the values that are going to go in the rows of not A and not B are the values that I'm going to get from A and B once I apply the not function. Okay, so this is how we're going to do this. So I have 4 positions here in the not A column. To find out what these values are, I'm going to look at the first value, the A, when A is 0, and then I'm going to apply the not A, and I'll get 1, because not 0 is 1. For the second value, again, A is 0, so not A would be 1. Third value, A is 1, so not 1 would be 0, right? It's the negation. And the last one, again, not 1 will be 0. I do the same thing for B now, right? Not 0 or not B, 1. Now B is 1 for the second number, not 1 is 0. Not 0 is 1. And not 1 is 0. All right, so I got a value for those, not A and B. Now I need to create this term, which is A, not B. Now, A, not B, it's just like in regular algebra when you have this expression xy. Now, what does xy mean? Now, this means x times y. So this is A times not B. And the multiplication is the and function, and the addition is the or function. Okay, so remember that. So multiplication is the and function, addition is the or function. So how do we get the values for A, not B? So this is how we're going to do this. We are going to, let me just erase this to make things a little bit easier. So this is how we're going to do. We're going to look at the A column, and we're going to look at the not B column. And then we are going to use those values, and let me just erase this and start from scratch here. 0, 0, 0, 1, 1, 0, 1, 1. So we're going to look at the A column and not B column because this is what we need here. And we are going to apply the AND function for these two columns. So first one, 0. So you have to remember what the AND is, right? So the AND is only 1 when both of them are 1. Otherwise, it's 0. So 0 and 1. 0 and 0. 1 and 1. So that's the one that's 1. 1 and 0. Okay. And I'm going to do the same thing for this term, not A and B. So now I am going to look at the not A column. Just erase this. I'm going to look at the not A column and the B column, these two. And again, because it's multiplication, I'm going to apply the AND function. So B and not A, or not A and B, it's the same thing. So 0 and 1, 0. Now remember, the AND is only true when both are true, meaning only 1 when both are 1. 1 and 1, that's a 1. 0 and 0, that's a 0. 1 and 0, that's a 0. Okay, so that's the value for that. Now, I need a value for this expression right here, A or B. So I'm going to have a column for that. And how do I do that? Well, I am going to look the same way as I did before. I am going to look at the A column, and I'm going to look at the B column, and I am going to apply on these two values the OR function. Now remember, the OR is only 0 when both are 0. So let's do the first one. 0 or 0, 0. 0 or 1, 1. 1 or 0, 1. 1 or 1, 1. All right. So we got the value for that. All right. So now what do? We already have a value for almost everything. We have a column for this. We have a column for this. We have a column for this. The next thing we have to do, we now have to have a value or a column for this whole term. Well, how do we find that? Well, I have a column for not A, B, which is this column. And I have a column for A not B, which is this column. So in here, I am going to write not A, B, A or B. And looking at these two columns, I am going to apply. Can you see which function I'm going to apply? What function is between them? So there is a multiplication right here, just as there is multiplication when you have something like this, right? It's multiplication right here. So multiplication is end. So I'm going to look at these two last columns and apply the end function for these values. So again, the end function is only 1 when both are 1. So 0, 0 and 0, 0, 1 and 1, 1, 0 and 1, 0, 0 and 1, 0. There you go. We got that column. Now, let's see what we have left. Okay, clear this a little bit. And so I have an expression for this. I have an expression for this. All I have to do now is the whole function. And that's perfect because I have a column for A not B. So A not B is this one. And I have an expression, I have a column for the other part, which is this, which is here. So I'm going to look at this column and that column, and I am going to apply the OR function between them. Again, the OR function is only 0 when both are 0. So let's go from the beginning. 0 or 0, 0 or 1, 1 or 0, 0 or 0. There you go. And this, like I said before, the value of the function has to be in the last column. So this is the last column, right? So this is function AB. This is exactly what we needed to create a truth table for, and it's right here. So this function, for all of the different combination of 4 inputs, it produces this output right here. So this is, when this table is done, we call this a truth table. So you have to do it like an onion, a little piece at a time. First, you create, a column for the not A or not B. Then you create a column for this. Then you create a column for this. Then you create a column for this. Then you create a column for that. And then you create a column for the whole function, and that will always appear at the last column. All right, so this is what a truth table is. A list that will have all of the possible function inputs and the final respective function output. All right, very good. So this is a function with 4 rows, 2 variables, right? 2 to the n. Now, let's see one case where we have a truth table where we have 3 variables. So remember, with 3 variables, 3 inputs, I am going to have a output. So I have to have a truth table that has 1, 2, 3, 4, 5, 6, 7, 8 rows. And again, you're going to list the values of the 3 variables from 0 all the way to the maximum. So 0, 0, 0, 0, 0, 1, 0, 1, 0, right? So this is the number 0, this is the number 1, this is the number 2, 3, 4, 5, 6, and 7. Okay, all of the possibilities. So I'm sure you can see that this is all of the possibilities that we can have for 3 variables. There are 8 possible values. Okay, perfect. I already know that if I need to create a truth table, the very last column is going to have the value of my function. So I'm going to immediately write it right here, because I know this has to be the last one. And I've done this before, so I know that I needed 4 columns. Okay, now I am going to need a column for XY, and I'm going to put this right here, right? And remember, this is X and Y. I am going to need a column for this, which is X, Y naught. And by the way, be very careful. This is X and Y and then negate. This is not the same as X naught and Y naught. Okay, just be aware, and you can create a truth table for this, create a truth table for that, and compare to see that they're not the same. All right, now I need a column for X, Y naught or Z. So X, Y naught or Z. And then the last one would be everything, which I already have it right here. Okay, so great. So I have label all of the columns. So notice that in a truth table, the very first row on the left side, you have the variables 2 or 3 or 4. And then in the middle, you're going to have all of the labels for the columns that you're going to use, which are the pieces of the function. And the very last column is going to be the actual complete value of the function. Okay, so the first row are always the labels. Okay, and then you have the numbers from 0 to the max in increasing proper order. We can't put them in any order. Okay, so now let's fill out these columns and find out the truth table. So the very first column we have is X and Y. And by the way, maybe you might have the following question. The professor, is it possible you just put XY right here? Could I have put XY here and X and Y not up there? Well, in this case, you cannot, because before we can find the value of this column, I need to know this column. So this has to come first. Okay, but for example, in the previous case, take a look at the case before, right? Take a look at the second case, the first example. All right, so let's take a look. I created my first column was not A and then not B. Could I have put not B here and not A there? Yeah, absolutely, we could. Could I have put a B first? Yes, we could. That's fine. All right, so normally we build the table in the way that we can build it. In this case, right, the XY has to come before the XY naught. But in the first example, you could rearrange some of these orders. This could be first, or this could be first, right? It doesn't really matter. Okay, so you have some flexibility in how you build your table. Sometimes you can do it. Other times, like in this case that I'm showing you here, the second example, XY has to come first. You have no choice. So let's get the value for XY. So the XY is X and Y. So I'm going to look at the first column, and then I'm going to look at the second column, and I'm going to apply the AND function between these two values. So again, remember that the AND function is only 1 when both are 1. Okay, so 0 and 0, 0, 0 and 0, 0, 0 and 1, 0, 0 and 1, 0. Now, 1 and 0, 0, 1 and 0, 0, 1 and 1, 1, 1 and 1, 1. Okay, so we got the first column. Just erase this. We got the first column. That's good. So now I have to do x, y, naught, which is very easy because I already have a column for x, y. So all I have to do is just negate the column x, y. Okay, so not 0 is 1, 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 not 1 is 0, not 1 is 0. Well, that was very easy. Okay, so we got a column for that. Now we have to have a column for this, x, y naught or z. Well, x, y naught is here and z is this column. So I'm going to be looking at those two columns and I am going to apply the OR function between. So again, remember that the OR is only 0 when both are 0. So all of these are already 1 in the xy. So everything here is going to be a 1. And you can check. 0 or 1, 1 or 1, 0 or 1, 1 or 1, all the way down to here. And then I have 0 or 0, that's a 0. And 1 or 0, that's a 1. All right, so we got the column, we got that column. And our last thing now is to get a column for the entire function. Okay, but the entire function is this piece, which is here, or this piece, which is here. So I will look at this column, and I will look at this column, and I will apply the OR function between them. Okay? That's all I have to do. So because the OR is 0 when both of them are 0, right, all of these are already 1s, so I'm going to have 1 all over here. And now I look at this 1 or 0, 1, 1 or 1, 1. So in this case, the whole function turns out to be a 1. Okay? Sometimes it happens. So if this happens, we call this a tautology. The name is not important. If they were all zeros, we would call it a contradiction. But in this case, all of the values are 1. Is it always 1? No. Most of the time, you're going to have a mix of values, just like we had in example 1. Okay, but in this case, everything was a 1. Okay, so this is a truth table. When this table is completely full, right, where you have the inputs for the variables in increasing order from top to bottom, and you have the last column of the truth table with the value of the function, you know, the outputs for the different combination of inputs, we have a complete truth table. So this is one way to represent a Boolean function, right? We talked about the algebraic. Let me just erase this here a little bit. We talked about the algebraic format. This is the algebraic format. And this is the truth table. So the truth table will display all of the different inputs and the respective output. So this is the first way to represent a Boolean function or expression. And later we'll see another way in another video.